You've got 5 different browser tabs open right now. You're exporting footage from one AI tool to another. You just want to stitch a single video together.
Yeah, it's a massive, glitchy headache for modern creators.
The final export usually feels completely broken and disjointed.
Oh, completely broken.
Today, we're exploring a totally new structural framework. Welcome to the deep dive, everyone. We're looking at the LTX Desktop video application, and we're diving deep into the LTX 2.3 model.
Right, this is going to be a really fun one.
We'll cover how it merges generation and editing natively. We'll see how developers smashed arbitrary hardware limits completely, and we'll explore some wild timeline native AI generation features. Finally, we'll ask what this actually means for human editors.
This completely changes how you think about creating videos. You never actually have to leave the video editor. You aren't wasting hours managing random exported files anymore.
So before the new workflow, we need some context. We have to understand the engine powering this system. Traditional editors usually just bolt AI onto old architecture. But LTX is built entirely around a multimodal model.
Which is a massive fundamental shift in software design.
Let's define what we mean by a multimodal model. It's an AI generating video, audio, and text simultaneously. That's a crucial definition for everything we discussed today. So LTX 2.3 brings 4 major systemic upgrades. First, they rebuilt the visual autoencoder from scratch.
Yeah, and that autoencoder controls the generated texture sharpness. Older models compress things way too aggressively during generation. You lost crucial edge details during the decompression phase. The result was a notoriously muddy or blurry texture.
Right.
But this rebuilt version handles raw pixel data beautifully. You get incredibly clean, sharp object edges everywhere now.
They also completely retrained the model's motion data. I'll admit, I still wrestle with prompt drift myself. It's so frustrating when models just freeze halfway through.
That was genuinely the biggest early user complaint. The AI would just forget the physics of a scene.
Yeah, it ruins the shot.
But LTX 2.3 keeps the generated movement completely natural. It understands how objects maintain momentum over time perfectly.
The third upgrade focuses entirely on native vertical video. It supports 1080 by 1920 perfectly out of the box.
Which is an absolute game changer for short-form video creators.
And the fourth major upgrade brings a HiFi-GAN Vocoder.
Right. That new vocoder creates incredibly clean audio sync. It reconstructs audio waveforms to match micro-movements perfectly. It successfully removes awkward silences and digital noise artifacts.
Why does training natively on vertical video actually matter? Why not just crop standard horizontal landscape footage?
Well, cropping horizontal video almost always ruins your composition. Native training helps the AI frame vertical subjects properly. The generated subjects fit the tall aspect ratio naturally.
So native training prevents awkward cropping and frames perfectly.
Exactly. Now, how do we get this running locally?
LTX Desktop is a fully local, open-source editor. There are absolutely no subscriptions or per-generation costs. You get complete and total privacy for your projects.
That privacy aspect is absolutely huge for studio workflows. You literally download the installer straight to your machine. The installation process is smooth, but the file is massive.
You're going to need about 70 to 150 gigabytes.
Yeah, it has to download all the required models. And Windows users must remember to run as administrator. That simple step prevents the software freezing during setup.
During that setup, you face a very interesting choice. You can use the LTX API for text encoding, or you can download a massive local encoder instead.
The text encoder basically translates your written text prompts. The API option is completely free for anyone. It saves you about 25 gigabytes of storage space.
But the local encoder guarantees a fully offline workflow. Wait, let me push back on that specific choice. So it's totally private and secure on my machine, unless I really want to save local hard drive space. In that case, my text prompts leave my computer.
Yeah, that's the exact technical trade-off you make here. The API sends just your text prompts to external servers. The actual video generation still happens entirely on your computer. But for total isolation, you must download that local encoder.
Is there any difference in video quality between them?
No, the final generated video quality remains exactly the same. It's purely a difference in local data routing and storage.
So the API choice only impacts local storage routing.
But there is a massive hardware roadblock sitting ahead.
Right. The official requirement is 32 gigabytes of VRAM. Let's clarify that term really quickly for the listener. VRAM is computer memory strictly dedicated to processing graphics.
That intense requirement basically demands an outrageously expensive card. You'd need something like an RTX 5090 to run it. Most normal people simply do not have that enterprise hardware.
This is where the story gets really fascinating. The open source community completely revolted against this hardware limit. They literally used AI coding tools to remove it. They built alternate forks like 1GP almost instantly.
They actually got it running on 12 GB consumer cards. People are using standard 30 series gaming graphics cards now. And that happened within a single week of release.
Whoa! Imagine scaling an enterprise-level software wall down to a consumer GPU in just 7 days. 2-sec silence. It completely changes how we view software development timelines.
It absolutely democratizes access to professional generative video tools. Mac optimization is also actively in progress right now. Apple Silicon users currently have to use the API connection, but native local support is coming very soon.
Does bypassing the VRAM gate slow down render times?
Yes, generating these clips will definitely take much longer, but it completely democratizes the software for everyday users. You trade rendering speed for actual software accessibility.
We're basically trading rendering speed for total democratization.
Yeah, so we bypassed the massive hardware limits successfully.
Now we're inside the actual video editor timeline interface. Let's look at where the paradigm shift actually happens.
You usually start in the gen space for quick renders. You render your clips at lower resolutions like 540p. Then you just use the built-in 2x video upscaler.
You also get all the standard video editing tools. You get color correction and auto letterbox formatting natively.
Okay.
But the new AI features are truly revolutionary here.
The first wild feature is the regenerate shot tool. You just right-click a clip directly on your active timeline. It re-rolls the generation without leaving the active editor.
You also get native image to video capabilities integrated. You literally just drag a static image onto the timeline. You add a prompt to create fluid, natural motion.
You can even mix in external video footage files.
Right.
You can easily bring in clips from Kling or Runway. They all live together seamlessly on this unified timeline.
The third feature is called the Bridge Shots tool. It's currently powered by the Gemini AI system natively. It analyzes the last frame of your first clip. Then it analyzes the first frame of your next clip.
It automatically generates the missing transition footage seamlessly between them. It literally fills the empty gap with completely new video. Right now, the version 1 frame matching is, admittedly, quite buggy.
Finally, we have the native Retake in-painting feature here. Let's quickly define in-painting so we're all on track. It means erasing a mistake so AI redraws that spot.
You regenerate just a tiny, isolated portion of the clip. The rest of your original video remains perfectly intact. There is a small, annoying UI scroll bug right now.
It's like stacking Lego blocks of data on the timeline. You never leave the room to manufacture new bricks. Does Bridge Shots understand complex lighting changes between clips?
The current frame matching struggles hard with complex lighting shifts natively. You definitely have to guide it with very specific prompts.
So current frame matching struggles with lighting without explicit guidance.
Exactly, it needs specific prompts.
We're going to take a brief pause here. This deep dive is supported by AI Mastery AZ course. Are you ready to level up your AI skills? Join the AI Mastery community to unlock exclusive tutorials. You can master tools like LTX Desktop and more. Learn from experts and connect with thousands of professionals. Start your AI journey today with AI Mastery AZ.
All right, we are back.
So an AI can bridge shots natively on a timeline. It can erase visual mistakes with a single mouse click. What actually happens to the human behind the computer keyboard? This creates serious anxiety in many creator communities today.
People naturally fear that AI will completely automate their jobs, but we really need to look at structural limitations here. Models like Kling and Veo generate incredibly short clips.
They usually max out at 5 to 15 seconds total.
Right, and they completely fail at multi-shot storytelling natively. AI lacks an inherent understanding of natural visual rhythm. It doesn't understand emotional pacing or deeper narrative structure.
It generates visually impressive but completely isolated standalone clips.
Exactly. Imagine chaining these short clips together automatically without humans. The system simply doesn't understand the rhythm of cinematic cuts. It misses the underlying emotional flow of the broader scene.
The human editor still completely controls the sequence vision. The AI merely refines and generates the raw video material. Even if an AI could perfectly chain scenes together seamlessly, Pete, it wouldn't understand the emotional heartbeat of a complex scene. It just doesn't know when a quiet moment should linger.
Right, and that lingering moment requires pure human empathy. Editing is fundamentally about feeling the specific emotional weight. The software just provides much better tools for human editors.
Does this mean the editor shifts from technician to director?
Yes, editors will spend less time managing tedious rendering files. They'll basically become high-level curators of these generated visual moments. The job becomes much more about high-level creative direction.
Human editors are becoming creative curators of generated moments. Let's pull back and synthesize the main takeaway today. LTX Desktop version 1 definitely has its annoying software bugs. The interface scroll glitches and hardware gates are quite frustrating. But the core structural concept of timeline continuity is revolutionary.
They introduced an amazing underlying concept called thinking tokens natively. These tokens actively look at the entire sequence you've built. They maintain character and lighting consistency across multiple different cuts.
This fundamentally changes how we approach multi-shot storytelling entirely.
You should definitely experiment with this powerful software yourself. It's completely free and totally open source to download today. You literally have absolutely nothing to lose by testing it.
If an open source community bypasses massive hardware gates weekly, will massive corporations actually dictate the future of creative software? Or will anonymous developers tinkering in free time lead us? You jump between 5 different browser tabs today to edit. Tomorrow, you might direct everything from a single, unified timeline. Keep exploring, keep creating, and keep questioning the tools you use.